Hello everyone. In this video, we will talk about the properties of beta 1 hat and beta 2 hat that we have estimated using the OLS method. Okay. First thing, as we have seen in the previous video, that OLS method corresponds to a particular sample, right? It means if you have, let's say, sample 1, you get some pair of beta 1 hat, beta 2 hat from that sample. From sample 2, you get another pair of beta 1 hat and beta 2 hat. This is pair 1 and this is pair 2, right? You can have many samples in theory, right? From each sample you will get a pair of beta 1 hat and beta 2 hat, right? So the values of beta 1 hat and beta 2 hat should be distributed in a distribution, probability distribution. Okay, so that probability distribution should have the mean and should have the variance. Okay, it means beta 1 hat and beta 2 hat must have a probability distribution. With some mean and variance. In this video, we are going to see what is the mean and the variance of the beta 1 hat and beta 2 hat. Okay. The next thing is in order to derive the sampling distribution of beta 1 hat and beta 2 hat, we need some assumptions about population term, error term ui and xi, right? No need of any assumption while estimating beta 1 hat and beta 2. हमने जब बीटा 1 हैट एंड बीटा 2 हैट को एस्टिमेट किया था, उस केस में हमें किसी भी अजम्पशन की नीड नहीं थी. ओके, लेकिन जब हम मीन एंड वेरिएंस को डिराइव कर रहे हैं बीटा 1 हैट एंड बीटा 2 हैट के, देन वी नीड सम अजम्पशंस. ओके, वी विल सी इन दिस वीडियो एज एग्जैक्टली वेयर we need those assumptions. Okay, before starting, let's recall some basic formulas from statistics. Suppose Li is a variable which is equals to L1 is a variable which is equals to sigma Ci yi. It means L1 is linear combination of yi. Okay, it simply means c1 y1 till cn yn. Okay, and suppose we have another variable L2 which is also the linear combination of your yi. This is equals to d1 y1 till dn yn. Okay, so in this case, if we want to calculate the expected value of L1, okay, it is equals to expected value of summation of ci yi, right? Okay, let's expand this. c1 y1 till cn yn, right? In this case, c1 and till cn are the constant terms, right? Yi is the variable, stochastic variable. Okay, so if you take expectation of this sum, you will get c1 times expectation of y1 till cn times expectation of yn, right? So this is equals to summation of ci expectation of yi. Okay, and expectation of yi is y ka mean, right? The mean of y. So this thing becomes equals to summation of ci, right, y bar. Okay, second, if we want the variance of L1, it is equals to expectation of L1 minus expectation of L1 whole square, right? But expectation of L1 is what? L bar, right? Now let's substitute the value of L1 minus L bar. Okay, so L1, in L1 you have C1 Y1 till Cn by n, right? In L bar you have C1 Y bar till Cn Y bar. So if you take the subtraction, you will get C1 Y1 minus Y bar till Cn Yn minus Y bar, right? Okay, so let's substitute this value here. C1 Y1 minus Y bar till Cn Yn minus Y bar whole square. Okay, if you expand this summation with the whole square, you will get something like this. Expectation of C1 square y1 minus y bar square plus c2 square y2 minus y bar square, right? Okay, in short, if you have a plus b plus c whole square, you get a square plus b square plus c square plus 2ab plus 2bc plus 2ca, right? So here you will get something like this first, and after that we have the 2 times cross terms. Okay, we have 2 times the cross terms. Okay, now if you take the expectation inside, you will get c1 square expectation of y1 minus y bar square plus c2 square expectation of y2 minus y bar square till cn square expectation of yn minus y bar square, right? And the value of these cross terms, will be 0, right? Why? Because yi data points are independent. Okay, it means covariance of yi and yj is equals to 0. ओके, आपके जो ये क्रॉस टर्म्स है ना, इन क्रॉस टर्म्स में आपके कोवेरियंस आएंगे बिटवीन y1 y2 कोवेरियंस बिटवीन y1 एंड y3 y2 एंड y3. ओके, आपके जो क्रॉस टर्म्स हैं वो सारे आपके ज़ीरो हो जाएंगे बिकॉज आपके जो yi डेटा पॉइंट्स हैं वो हमने इंडिपेंडेंट अज्यूम किए हैं, राइट? अगर वो इंडिपेंडेंट हैं इट मीन्स वाई आई एंड वाई जे किसी भी दो डेटा पॉइंट्स के बीच में जो कोरिलेशन है वो आपका कोवेरियंस है वो आपका 0 आना चाहिए. ओके, नाउ व्हाट इज द वैल्यू ऑफ expectation of y1 minus y bar square, right? This term here, it is the variance of y1. This is the variance of y2 and so on, right? वेरियंस ऑफ y1 क्या होता है आपका? व्हाट इज द वेरियंस ऑफ y1, y2, y3? व्हाट इज द वेरियंस ऑफ yi? आपका जो वेरियंस होता है yi का, हमने अजम्पशंस में पढ़ा था, इट इज कांस्टेंट, राइट? एंड इक्वल्स टू सिग्मा स्क्वायर, राइट? सो आपका वेरियंस ऑफ L1 क्या हुआ? सिग्मा स्क्वायर, राइट, टाइम्स समेशन ऑफ सी आई स्क्वायर. ओके, सो इन शॉर्ट, वेरियंस ऑफ ax plus by is equals to a square variance of x plus b square variance of y plus 2ab covariance of xy. Now let's have a look at the variance of yi. Okay, so variance of yi is what? It is the expectation of yi minus expectation of yi whole square, right? So what is the expectation of yi minus yi minus expectation of yi? Your yi is equals to expectation of yi, right, plus error term. This is from your population regression line, right? So this entire thing becomes equals to uy whole square, and this is equals to sigma square, right? At this point we are using the property of homoscedasticity, right? It means आपके हर एरर टर्म का जो वेरिएंस होगा वो सिग्मा स्क्वायर होगा, राइट? इट मीन्स आपके हर वाई आई डेटा पॉइंट का जो वेरिएंस होगा वो आपका सिग्मा स्क्वायर होगा, ओके? सो these are the two things these are the 2-3 things actually which we should know before calculating the variance of beta 1 hat and beta 2 hat, okay? So now we will see about the variance of beta 2 hat, okay? First thing, your beta 2 hat is equals to sigma xi yi upon sigma xi square, right? This thing is equals to sigma xi yi upon sigma xi square, okay? Now please note that this sigma xi square this thing is equals to x1 square plus x2 square till xn square, right? This entire thing, it is just a number, right? आप x1 स्क्वायर करेंगे, x2 स्क्वायर करेंगे, x3 स्क्वायर करेंगे, xn स्क्वायर करेंगे, उन सबको ऐड करेंगे, you will get a number, right? So this thing in the denominator is just a number, okay? Now let's have a look at the numerator part. In numerator you have something like x1 y1 plus x2 y2 till xn yn, okay? So it means this formula is equals to x1 y1 divided by sigma x1 xi square plus x2 y2 divided by sigma xi square till xn pi n divided by sigma xi square, right? Now note that these are the weights, right? आप इन वेट्स को बाहर ला सकते हैं वाई आई से, आप इनको वाई आई से अलग कर सकते हैं, राइट? मैं इस एंटायर थिंग को कैसे लिख सकता हूँ? Like I'm assuming this is my C1, this is my C2, this is my Cn, right? So this thing becomes equals to summation of Ci yi, where Ci is equals to xi upon sigma xi square. Okay. At this point, I am using one assumption. We are using the assumption that xi's are non-stochastic and fixed in repeated sampling. ओके, इट मीन्स सैम्पल 1 एंड सैम्पल 2 को जब आप कंपेयर करेंगे तो आपके जो एक्स आई डेटा पॉइंट्स हैं उनकी वैल्यू सेम होनी चाहिए, राइट आपके सिर्फ जो वाई आई डेटा पॉइंट्स हैं सिर्फ उनकी वैल्यूज़ डिफर करेंगी सैम्पल 1 एंड सैम्पल 2 में. ठीक है, वी आर यूजिंग दैट अजम्पशन हेयर. ओके, सो अब दिस फॉर्म इज फैमिलियर टू यू, राइट. It is a linear function of yi, right? So it means beta 2 hat is linear function of yi. Okay, so हमने beta 2 hat को yi का एक linear function बना लिया, right? Okay. Now let's have a look at the variance of beta 2. Now, since beta 2 hat is equals to summation of ci yi, right? It means variance of beta 2 hat is equals to, we are using the formula, right, जो हमने derive किया था. We are using this formula, right? So it is equals to your sigma square summation of ci square, right? Now we just need to calculate the ci square, right? आपके ci की वैल्यू क्या है? इट इज़ xi डिवाइडेड बाय xi स्क्वायर, राइट. इट मीन्स आपके ci स्क्वायर की वैल्यू क्या होगी? वी आर स्क्वायरिंग एंड न्यूमरेटर एंड डिनोमिनेटर. ओके, अगर हम अब इसमें समेशन करें इस टर्म का तो वी विल गेट समथिंग लाइक दिस, राइट. It means the value of your sigma ci square is 1 divided by summation of xi square. It means variance of beta 2 hat becomes equals to sigma square divided by sigma xi square, right? This is the value of your variance of beta 2 hat. Okay. Okay. Similarly, let's have a look at the variance of beta 1 hat. Okay, first thing, we need to define beta 1 hat as a linear combination of yi's. Okay, so your beta 1 hat is equals to y bar minus beta 2 x bar, right? This is from normal equation 1. Okay, so what is your y bar? It is sigma yi divided by n minus, what is the value of your beta 2? It is equals to this thing, right? So this thing become equals to summation of 1 by n minus x bar divided by summation sigma xi square times yi, right? So in short, we can assume that your beta 1 hat is equals to di summation of di yi, where your di is equals to 1 by n minus x bar divided by summation of xi square, right? Now what is the value of variance of beta 1 hat? It is equals to sigma square, right, summation of di square. Okay, we just need to find the value of di square. So summation di square, right? So what is the value of di square? It is equals to 1 by n minus x bar divided by summation xi square whole square, right? Which is equals to 1 by n square plus x bar square divided by summation xi square whole square minus 2 times 1 by n times x bar divided by summation xi square, right? So what is the value of sigma di square now? Right, हमें summation करना है दोनों साइड. So this is equals to n upon n square plus this term, this entire term is constant, right? It consists of x's, na? This entire term is constant, right? So this become equals to n times of x bar square divided by summation of xi square whole square, right? Sorry, one more thing, this should be equals to xi should be here. Xi should be here, sorry, I forgot this xi. Okay, minus 2 by n times x bar times summation of xi square, right? But we have something जिसको हम sum कर सकते हैं in the last term. Okay, so let's have a look at this again. Your first term should be equals to n upon n square, right? In your second term, your x bar square divided by xi square whole square, this term is constant, right? And we have xi square here, we can sum over xi square, right? And in the last term you have 2 by n divided by summation of xi. Okay, this thing is 0 because summation of xi's are 0, small xi's, right? So this term is equals to 1 by n plus x bar square divided by summation of xi square, because स्क्वायर से वन टर्म आपकी कैंसिल आउट हो जाएगी. सो दिस इज द वैल्यू ऑफ योर सिग्मा di square. Okay, so in this case your variance of beta 1 hat becomes equals to sigma square 1 by n plus x bar square divided by xi square. This is the value of your variance of beta 1 hat. Okay, I hope this becomes clear to you now how to derive the variance of beta 1 hat and beta 2 hat. Okay, now standard error of beta 1 hat is equals to under root of variance of beta 1 hat, right? Standard error of beta 2 hat is equals to variance of beta 2 hat. Okay, now one more thing, as you have seen that beta 1 hat and beta 2 hat differs from sample to sample, right? So is there any relation? Now the question is there any relation between beta 1 hat and beta 2 hat? बीटा 1 हैट एंड बीटा 2 के हैट के बीच में कोई रिलेशन एग्जिस्ट करता है या नहीं, राइट? वी नीड टू सी, हमें ये चेक करना है, ठीक है? इन अदर वर्ड्स व्हाट वी आर ट्राइंग टू सी, कोवेरियंस ऑफ बीटा 1 हैट एंड बीटा 2 हैट, राइट? हम बीटा 1 हैट एंड बीटा 2 हैट के बीच में कोवेरियंस एस्टैब्लिश कर रहे हैं. ओके, okay, so what is the value of covariance of beta 1 hat and beta 2 hat? It is equals to covariance between summation ci yi, right, summation di yi, right? It is equals to covariance between ax and bx. This is equals to variance of x times ab. Okay, if we apply this formula here, we will get variance of y square, variance of y times summation ci di. Okay, so now we have the variance of yi as sigma square. We just need the value of summation of ci and di, right? So what is the value of ci and di? The value of Ci was xi divided by summation xi square, right, times the value of di was 1 by n minus x bar xi divided by xi square. Right. This thing is equals to summation of xi upon में n xi square minus x bar summation of xi square divided by summation of xi square whole square, right? Let's take the summation inside. You will get something like this. Sorry. This is equals to x bar summation of xi square upon summation of xi square times summation of xi square, right? This thing is 0, right? And we cancel out 1 from this, so it is equals to your x bar divided by summation of xi square. So the value becomes equals to sigma square times minus x bar divided by summation of xi square. Okay, so these are the values of your covariance of beta 1 hat and beta 2 hat, right? Please note the negative sign here. It means they have a negative correlation. Negatively correlated, right? आपके बीटा 1 हैट and आपके बीटा 2 हैट, these two terms are negatively correlated. ओके अगर एक ओवर एस्टिमेट होगी तो आपकी दूसरी अंडर एस्टिमेट होगी एक सैंपल में. ओके नेगेटिवली कोरिलेशन का मतलब यहाँ पर ये है. ओके ओके नाउ what about the expectation of beta 1 hat and beta expectation of beta 2 hat? Let's see. Your beta 1 beta 2 hat is equals to linear combination of yi, right? So what is the value of expectation of beta 2 hat? This should be equals to summation of ci expectation of yi, right? Again we are using the assumption that xi are non-stochastic. Okay, so what is the value of expectation of yi? It is equals to beta 1 plus beta 2 xi, right? Now if we solve this thing, we will get beta 1 hat summation of ci plus beta 2 summation of ci xi, right? So your ci is equals to xi upon sigma xi squared, right? So your sigma ci equals to sigma xi divided by sigma xi square, right? This is equals to 0. Okay, now let's see about your ci xi. What is ci xi? It is equals to xi times xi divided by summation of xi square, right? You can rewrite this as this, right? And you can write it as this thing, right? Now let's take the summation of this, right? And divide and multiply the second term by n. You will get something like this: summation of xi square minus n times x bar square divided by summation of xi square, right? This numerator part is equals to sigma xi square, right? Divided by sigma xi square. This is equals to 1. Okay. It means this term is equals to beta 1 hat times 0 plus beta 2 times 1. Beta 1 times 0, sorry, equals to beta 2. Okay. Similarly, your beta 1 hat is equals to summation of diyi, right? So your expectation of beta 1 hat is equals to summation of di expectation of yi. This thing is equals to beta 1 plus beta 2 xi, right? So beta 1 times summation of di plus beta 2 times summation of di xi, right? What was the value of your di? What was the value of your di? It was 1 by n minus x bar times xi upon summation of xi square, right? So what is the value of your sigma di? Let's take the sigma. It is n by n minus 0. Okay, what about sigma dixi? Let's first calculate dixi. It is equals to xi divided by n minus x bar xi times xi divided by sigma xi square, right? Let's take the sum. Right. Now observe that this term equals to 1 from your ci xi, right? So it means this becomes equals to x bar minus x bar equals to 0, right? So it means we have beta 1 hat times 1 plus beta 2 hat, beta 2 not hat, beta 2 times 0 equals to beta 1. Okay, so this is the value of, this is the sampling distribution of your beta 1 hat and beta 2 hat. So in conclusion, let's conclude this. Beta 2 hat, right? Expectation of beta 2 hat is your population beta 2, right? Variance of beta 2 hat is equals to sigma square times summation of xi square. What about beta 1 hat? Expectation of beta 1 hat is equals to beta 1 and variance of beta 1 hat is equals to sigma square 1 by n plus mean of x square divided by xi square, right? And covariance of beta 1 hat and beta 2 hat is equals to sigma square minus x bar square divided by summation of xi square. Thank you.